Hello friends, so today we are going to discuss the question from rotational motion, and this question is from 2020. We are going to solve only one question, and that is from Advanced 2020. And the question states, a small roller of diameter 20 centimeter has an axle of 10 centimeter. See figure below on the left. It is on the horizontal floor and a meter scale is positioned horizontally on its axle with one edge of the scale on the top of the axle. See figure to the right. The scale is now pushed slowly on the axle so that it moves without slipping on the axle. The roller starts rolling without slipping. After the roller has moved 50 centimeter, the position of the scale will look like. The figures are schematic and not drawn to scale. So basically we are interested in this figure only. So we have a scale which is on this internal one, okay, or we can say it is somewhere here. So it is going to rotate. We are going to apply the force. This axle is going to move forward, and according to the scale will be also trying to move. So we have to find out the position. What will be the position of our scale? This is the basic question here. And we have to remember that roller is going to roll without slipping on the horizontal floor. Okay, and the diameter of the roller is 20 centimeter and the axle diameter is 10 centimeter. Okay, and from the figure we can at least see that the scale is having a total length is close to 100 centimeter. Okay, from this last figure we can just make an approximate assumption based on the figure given to us. So let us consider first of all roller on the floor, and that entire motion is rolling without slipping. So you can see our roller on floor, and it is said that first of all without slipping, and it moves the distance, center moves the distance 50 centimeter. You can see center moves a distance, let us call distance d, which is given to us as 50 centimeter. And let us assume that it rotates through an angle of theta. Roller rotates through an angle of theta, angle of which we assume as theta. Therefore we can write that d will be equal to r times theta, and d is our 50, radius is our 10, so we get our theta is equal to 5 radians. Okay. Now we can easily find out its angular velocity. angular velocity, and we can say V center will be equal to r times omega, and one second, sorry, I've written angular velocity is omega. Therefore, we can say linear velocity of the roller center that is our V center will be equal to r times omega. So this comes as our 10 omega. Okay. And in this case, we have to remember that this entire you can say system consists of two parts. One is the axle part and other one is the roller part. Okay. So this is a roller part which is in contact with the surface, but that is the axle part which is in contact with the scale. Okay, so we have to remember this one. The roller is in contact with the flat surface, but axle is in contact with the scale. Okay, and we are given that roller rolls without slipping. Therefore, the point of contact with the floor at any instant is at rest. Point of contact with the floor instant is at rest. Therefore, we can write that velocity of a point on the rim or we can say on the roller's rim which is at radius 10 centimeter relative to the center is r omega, and relative to the floor points on the rim move at so for point which are at top of the roller, they move at 2r omega, which comes as 20 omega, and bottom, which is basically in contact with floor. It's 0. Okay, this is a centimeter per second, and this is also centimeter per second, and direction will be forward, that is towards right side. Now we come to the axial motion. Axial motion, and radius is 5 given to us, and obviously it has to be rotating at the same frequency, angular frequency, with the roller. Okay, so this is important part here. So it rotates with same angular frequency omega as the roller. Their frequency, angular frequency, should be same. Now once again we can find out the velocity at the top of the axle relative to the roller center, and then we can modify it to the floor part also. Okay. So we can say at point on the top of the axle, and this axle is at a distance r is equal to 5 centimeter from the center. As a velocity relative to roller center. We can say V axle top relative to the center. That will be equal to our r omega, which comes as 5 omega centimeter per second. Now we come to the relative to the floor. We can say relative to the floor, the velocity of the top of the axle is the sum of center's velocity and tangential velocity due to rotation. Therefore, we can write that velocity of the axle top, and now it is relative to the floor, will be equal to velocity of the center plus tangential velocity r omega, which comes as 10 omega plus 5 omega, giving us 15 omega centimeter per second. Second. I think I forgot to, yeah, it is here, 10 centimeter velocity of the center. And now we come to the scale motion of the axle. Scale motion on axle. Okay. And in this case also, the scale is in contact with the axle and it moves without slipping relative to the axle. So we have to remember that scale is in contact with top of the axle, top of axle, and moves without slipping relative to axle. Relative axle. Okay. So which basically means that we found out that the axle top with respect to floor is moving with the relative speed of 15 omega, and our scale is in contact with the axle and it's the top. Therefore, with respect to floor, its velocity will be also equal to 15 omega. Therefore, we can say that velocity of scale will be also equal to 15 omega centimeter per second. Okay. And let us call this as V scale. So we can say our V scale is equal to V axle top floor, V axle top floor, which is our 15 omega per centimeter per second. Now relative to the center of the roller. Relative to the roller center and the scale's velocity let us call this as velocity of scale, and this is relative to the center, which will be equal to 15 omega minus 10 omega. So we get velocity of the scale relative to the center is equal to 5 omega centimeter per second. And so this relative motion is going to result in the scale sliding over the axle surface. So you can see this relative motion. Motion is equivalent to the scale sliding over the axle. And we know that the axle surface at the contact point moves 5 omega centimeter per centimeter. Okay. So we can use, let us find out the, now we are going to find out the displacement of the scale. Displacement of scale. And we know that roller moves 50 centimeter, let us suppose in time t. Therefore, and we also found out that velocity of the center is our 10 omega. Therefore, we can write that our 50 will be equal to 10 omega multiplied by time t. And from here, we can say that our t will be equal to 5 upon omega seconds. And scale's velocity relative to the floor is 15 omega. Scale's velocity relative to floor is our 15 omega. Therefore, distance the scale moves in time t. Distance the scale moves in time t. And we can say this as d for scale relative to the floor will be equal to velocity of the scale multiplied by time t, which gives us 15 omega, and we have this as 5 upon omega, giving us 75 centimeters. And this is with respect to floor. Now we come to with respect to roller center. Relative to roller center, scale moves we can call this as d of scale with respect to center will be equal to 5 omega, and time is 5 upon omega. This comes as 25 centimeters. So we come to now the position of the scale. Position of scale. And initial position we know that scale is basically horizontal, and we assume that the left edge is at x equal to 0, because if I see the figures also, we can understand that the left edge is put at x equal to 0. Initial position, we can say the left edge is x equal to 0. Okay. And now coming to the after motion, that is final position. After motion, that we know that now the scale moves by a distance of 75 centimeter. Okay. After motion, we can say that our x with respect to floor is at a distance of 75, and our x with respect to the center of the roller is at a distance of 25 centimeter. Therefore, we can say that and here we have to remember that roller center, it moves by a distance of 50 centimeter. Okay. Therefore, we can say that in a roller frame, we are going to get this as our x center plus our x center and our roller. So we can this as 25 plus 50 is equal to 75 centimeters. So we get that our option number B is correct. B is correct. And in this case also we can make sure that if we want to find out the rightmost edge also, we can make a random, we can say, guess that if it moves from 0 to this, so total distance from left edge will be 75, so the rightmost edge should be at 175. Okay, so this cannot be 100. Obviously these two are incorrect, okay, because and in this case, this answer, if this figure would have been something like this, that our left edge is at 25, okay, and the rightmost edge will be about 1 second. Yeah, so this is not matching because of the relative motion with respect to the right of the center. Okay, so this option is incorrect. This we can clearly see this cannot be equal to 50. So this completes the question. Thank you.